Hey everybody, welcome to our Computer Network Design Basics. This is week 3 of ISDT 7315, Educational Network Design. And we're so glad you can be here with us and learn with us. I am Stephanie Galavan-Russell.
Hi, I'm Karina Cube Garza, your cohort 6 peer. And I would just like to say that I thought I knew a lot about computers until I read about this stuff. So
Same.
hopefully we don't lose any of y'all in this topic. It was a lot. It was the readings were very dense, at least the textbooks that we found. So just bear with us.
Yeah. And if any of you are big nerds like we are, some of this will sound familiar and make sense. If not, good luck.
I know. Yeah, so we will be linking a super duper awesome Wakelet collection that we curated for you all in case this is a little too confusing. In the Wakelet collection, we do have informative videos, which are really cool. A couple of really cool YouTube videos that I found that I use just to help me make sense of the stuff. Some infographics and also some recommended textbooks. Actually, the textbooks that we recommend today, highly recommend that you read the first chapter of each. Each image in the presentation today, which we'll be linking in the discussion, is permalinked. So it'll take you directly to the Newton Library entry where you can check out the book because this is where we got most of the information. Yeah, it will require you to log in if you're not logged in already. And the first chapter of each book that we linked to this presentation is where we're basing this information off of. I would recommend that you all kind of download it or check it out and see if any of your topics may be featured in these textbooks. They were really, really good. There's a lot of information, which I know we can't wrap up in 10 or 15 minutes, but they were really good. Plus, these were the most recent ones I found that were relevant to what we're talking about. So yeah.
And we thought that this quote was really interesting. There are two sides of computer revolution. One is represented by the PC on your desktop, and the second one by the device that remote controls your TV, monitors and operates your car engine, and allows you to set up your answering machine and your microwave oven. So when we're talking about computer network basics, we're not just talking about computers, we're talking about everything. If you're familiar with the term the Internet of Things and how we have, the Alexas, how we have Roombas, things that are controlled by Wi-Fi, then that's what that means. So it's computer networks aren't just computers anymore, it's everything.
Yeah, it's a whole network of communication, basically. Now, in this module, we're basically going over computer network fundamentals. And in this case, we're talking about what is a computer network. So basically, a computer network is a collection of devices that are connected to each other, either wired or wirelessly, in order to allow every device to communicate with each other. So that's basically what it is, according to MUSA 2018. And so based on the readings, we made up this acronym, which I'm like low-key loving. We are coining the term computer network temp. And what each textbook suggested was that a computer network is made up of types, topology, equipment, models, and protocol. In this case, the sizes, which determine the type, the devices or hardware, the different models that facilitate communication among the systems, and then the feedback messages that are included in protocols.
And the temp is what we are going to be going over today. So the next modules or sections of this presentation are going to be over the types, equipment, models, and protocol.
Yes.
So the first thing we're going to talk about is the T, which is the types. So if you were a big gamer growing up like we are, like that we're nerds, you might remember the term a LAN party. And a LAN party was when a bunch of nerds like us would bring our computers to someone's house and we would sync together with wires and create our own computer network and play games together. Now, if you are younger than us, you have no idea what I'm talking about, but that is that is basically what a LAN is. And a LAN is your local area network. It's when you are in the same space, everybody brings their computers together and you hook up using wires. So you're creating a network among people in the same space. So it's usually in a building or on a building floor or in a few buildings. So it's kind of like at school when we're all on the same network, but that network does not continue anywhere else outside of that building. Then you have the wide area network, your WAN. This is when one or more clusters of network elements and scattered over wide geographical area. So this is when things are connected via the internet. So it's not constricted to just one building anymore. The media does move a lot slower, and it is often unreliable because your network is now so wide. Then we have your MAN, which is the metropolitan area network, aka the Goldilocks network, and it is slightly wider than a LAN, but it's not so wide as a WAN. So it's kind of in the middle of these two, and it can cover an entire city. So if maybe you're working for a company that has different parts and different parts of the city, kind of like how here in Austin, we've got different parts of the Austin Public Library, different branches scattered throughout the city, they're on their own network. So they would be on a MAN.
Yeah, I would also like to say that we coined the Goldilocks network.
Yes. So here's some more examples of how these networks work. So here's your LAN. So it's going to be connected, all the computers, all the devices on this network are going to be connected by their wiring, by their being plugged into the same place. Here's your WAN, and here's a really cool illustration. And it's primarily going to be used over the internet, but again, they are going to be connected via a network.
Yeah, and
And
I
then
think
the
the
last
MAN
one. Yeah.
Oh no,
Go
no,
ahead.
yeah, no, I was just gonna say that neither textbook offered like a really cool illustration like the other two, so I had to get this one from Science Direct.
Yeah. So this one is demonstrating how things are spread out.
Yeah, but I like how it connects them.
Yeah, it was really cool.
Yeah.
And then some other types of networks, there's personal area networks, kind of like what you might have in your house, your own personal network. A VLAN, which is your virtual local area network, which is same as a LAN, which is, remember, your local area network, but configured with a virtual software. So this one is all virtual. And then you have a storage area network, which is your SAN, which is a network of storage devices that connects them to the servers. The second T, go ahead.
Topology. Yeah, topology. So this one was a little confusing for me, I'm not going to lie, but there are two major categories of computer network topology. And in this case, it's physical and logical. Physical meaning the actual layout, the physical layout of wires or media, and then logical meaning the way the hosts access the media to send data. So it's the representation of flow of data on a network. There are 5 popular types that were mentioned actually in both mesh, tree, bus, star, and ring. So on the next slides, there's examples of each. So for example, mesh, so you can kind of see it does look like a little mesh screen. Multiple access links between network elements often applied in MAN networks. So you can kind of see they're all kind of like interconnected between the networks themselves. The bus is actually connected by a single thick backbone cable. So all of these devices are connected via that one cable. The next type of topology that's popular is the star topology, in which all elements are connected to a central element. In this case, all laptops connected to a server. And the tree, which is more common than the others, it's put in a hierarchical structure where there's like a root, kind of like with the actual physical tree, in which they all share a child-parent relationship, which I thought was pretty interesting considering. But yeah. And then the ring one takes turns in sending information in a ring. And if one of these goes out, basically the entire system fails. So yeah, I kind of thought of it as like a circuit, right? Like a, oh my God, what is it called? Oh yeah, a circuit, and then, you know, one goes out and the whole thing goes out. Kind of like
Yeah,
Christmas lights. Yeah,
kind of like at school.
that's cool. Yeah, if you take one thing out, right? All
So
right,
then
so
we're gonna talk about equipment. So there are two different types of computer network equipment. You've got your end or your user devices. These are things that we use: laptops, iPhones, TVs, iPads, scanner, printers. These are the things that you are directly working with. So your phone, anything that you are directly putting that information into. Your hardware is what is inside the computer or the device that you're working on. So your interface cards, your repeaters, hubs, bridges, switches, routers, gateways, firewalls, and servers.
All right, so there are different models that computer networks adhere to, and the most popular ones that were mentioned were the OSI model, which is the Open Systems Interconnection. So the way they, both authors actually described these different types of models was that they implement protocols in layers. So the OSI works in 7 layers. So you have your physical data link network, transport, session, presentation, and application. And each one has a significant function. However, this goes from like ranging from converting those electrical analog impulses to providing the network services for applications. So you're thinking of it as kind of like a chain reaction of physical cabling to the file transfer. So everything that goes in between that communication, everything that goes into that communication of computer networking. And then the next one that was another one that they say is pretty popular is the TCP/IP model, which stands for Transmission Control Protocol, Internetworking Protocol. I swear I have like a new um, appreciation for my MIS department in my district because I have no idea what any of this stuff means.
Truth, while we were
But
going over these, I wanted to text my tech from school and be like, did you know this?
yes,
Do you know these things?
yes,
Because now I know.
yeah, yeah. I mean, I can't even imagine what they do to like ensure that the whole district technology is functioning. But anyway, that's a discussion for another day. But unlike the OPI, this one is actually in 4 layers, right? So it's only from the physical link to the application. And then the last one is more, oh yeah, and then there's a comparison between how the OSI models layers compared to the TCP layers and how each one compares to the other. And then the hierarchical model is actually only 3. So it's just 3 layers. Oh, sorry, typo. Access, distribution, and then you have your core or backbone.
All right, and the last part, the P of temp, is your protocols. So your protocol is a set of rules that govern the data communications. So these are what control everything, all of your communicating that's happening on your devices. So your key elements are syntax, semantics, and timing. Your syntax is the structure or the format of the data. Your semantics are the meaning of each section of bits. For example, does an address identify the route to be taken, or is it telling the final destination of the message? And then timing has 2 characteristics: when the data should be sent and how quickly it's being sent. So again, these are your 3 things that are controlling the communication that's happening.
All right, now Big Brother. And the reason that we say Big Brother is because like there's all these different protocols, models, different things that go into computer networking, but then it's like who decides these standards? So there's different organizations, forums, government agencies that oversee these requirements. And the ones that we came across were IOS, which are the International Organization for Standardization, the International Telecommunication Union, Telecommunication Standards Sector, American National Standards Institute, Institute of Electrical and Electronics Engineers, and Electronic Industries Association. And the only reason that we're putting these and kind of suggesting these is because we're all going to have to be moderating a topic. So maybe you'll find something in these, within these organizations that you might find useful for your topics later throughout the semester.
And it's helpful also to know, like, the internet isn't just one big wild west, right? There are people and there are um, organizations that do kind of take care of the internet and monitor it.
Right. So
So
we,
go.
oh no, no, okay. So yeah, no, so I was just going to say there's a lot of information presented in the chapters that we read based on the 2 textbooks, and we in no way covered like 10% of what was in there. These are just some of the major definitions and concepts that we came across. We highly recommend that you go through those and see if there's anything additional that you might find interesting. So our week's discussion activities are after viewing this presentation, the Wakelet resources that we recommended, and reading through chapter one in each recommended textbook, offer your responses to the following questions. 1, what is your experience with computer networks? Because I'm sure we have many, whenever the system fails, right? What was it about it? It'd be interesting to know how to fix it yourself, right? 2, what is something new you learned? Because I guarantee you there will be a lot if
Yes.
you go through the stuff. But yes,
And
so we,
and you don't have to talk about how you use these professionally. It can be like the example I shared about a LAN party. If you were a nerdy gamer like we are and you remember LAN parties, talk about how maybe you have set up a LAN party before, or you've used one or been a part of one or heard of one. Just we
yeah.
want to know, what is your experience with these things, because they're things that we don't think about all the time and how the networks are working or how they exist. But now it's cool that we're going to be aware of them.
Sorry, I sneezed. Okay.
It's all good.
Anyway, well, thanks for learning with us, y'all, and we look forward to y'all's discussions. And don't forget to look through the resources that we post, and we look forward to your discussion and what you have to say.
Bye.
Bye.